Good evening to all. So today we are going to start with some note point based on that above last four methods, finding the roots of the equation, and followed by one more questions, order of convergence, which is faster method and which is slower method. I already discussed it. Due to that I am giving some order of convergence, one more questions, and then Euler's method, Runge-Kutta method, solving for ordinary differential equation I shown you yesterday, one example consideration, and Simpson's trapezoidal rule. Okay, followed by probability, basics, introduction, definitions. So all of you put note point. NR method, that is Newton-Raphson method, is better than the remaining methods but it is applicable for only for the curves, that is function f x, the curves which are having large slope values, that is while the graph crosses the x-axis, comma, if it is nearly vertical. And it requires few iterations to reach the root. Next, secant method is better than RF, regular falsy, and midpoint method, that is bisection method. Bisection method converges slowly. These are the note points. Next, I am giving method followed by order of convergence. Just divide your page into two columns, into two parts. First part is method and the second part is order of convergence. This is very, very important. Just I am giving one more questions. Actually the proofs are takes minimum one page, that is descriptive only, but one more questions you just by heart the order of convergence. First method, what we have done? Bisection method. Linear, that is convergence is linear, that is order 1. This is also denoted by O1. 2, regular falsy method, same, this is also linear, that is in O notation order 1. 3. Secant method superlinear, that is more than 1, that is order 1.62 approximately. And the fourth here I am writing Newton-Raphson. Order of convergence is quadratic, that is order 2. So please remember the order of convergence in the 4 methods, that is 1 mark questions. So far the question came secant method order of convergence and Newton-Raphson convergence. So that is why Newton-Raphson method is faster than the other methods. Order of convergence is fast in Newton-Raphson method. If you refer textbooks, proofs are available, but it is descriptive question only. Whenever the order of convergence prove that like that, 8 marks, 16 marks questions only. But for gate purpose, just by heart this order of convergence, okay? Because proofs are neglected. I mean proofs are not included in gate. The next one is solution to ordinary differential equation, or you can write numerical. Of course, all these are numerical methods only. Numerical solution to ODE, numerical solution to evaluate the definite integral, numerical solution to evaluate one of the roots of the equation approximately in 2 iterations. After first iteration or up to 3 iterations, the questions coming like that due to 1 or 2 marks only. Okay. Consider the differential equation EQ stands for equation. Dy by dx is equal to f of x comma y with the initial condition y of x naught is equal to y naught. Just say this equation is star. Now in all the methods of the second topic, your equation is in this standard form. What is the standard form of your equation? Dy by dx, that is derivative only in the left side. If any other terms, bring into right side, and then that right side term is denoted by f of x comma y with the starting values of x and y, that is x naught, y naught. These are called initial conditions. Okay, so that means the need of this topic is we are going to find a y value at a particular x. Suppose x is equal to 0.1, what is the corresponding y value? So depending on the method and depending on the step size, it requires or it needs how many steps. That means how many steps means sometimes we need to find y1, y2 and y1, y2, y3 depending on the step size h, depending on your x value. Okay. Equation star can be solved by 1. Euler's method. So at a time I am giving all the methods how to solve this equation. Then I will give you problems, which is also known as forward Euler's method or explicit Euler's method the forward Euler's iterative formula is yi plus 1 is equal to yi plus h times f of xi comma yi for I is equal to 0, 1, 2, so on. So let me give all the methods, the iterative formula, then I will mention x1, y1, x2, y2, like that, and h also. Okay. So this is the iterative formula for solving this equation star using forward Euler's method, which is simply known as Euler's method. Okay. Backward Euler's method. This is also known as implicit Euler's method. Now the formula I am giving. The backward Euler's iteration formula, comma, is yi plus 1 is equal to yi plus h times f of xi plus 1 comma yi plus 1 for I is equal to 0, 1, 2, so on. In Euler's only 3 types of methods. Okay. Modified Euler's method. Other name is improved Euler-Cauchy method or Euler's predictor corrector method or Hewin's method or Range-Kutta second order method. So many names. So here also you can write